Hi, my name is Guillaume Saint-Jacques, or William in English, and I lead the computational social science team at LinkedIn. And I'm very happy to be joining this conference today to talk a little bit about the way we try at LinkedIn to build a more inclusive platform by taking a specific approach to looking at our experiments. And so, first of all, I want to mention that this is that there is a paper online if you'd like to take a look at it. So I'm leaving the archive link, and so I'm very happy to answer any questions. And if not, there are plenty of details as well that are available online. So to get us started, the vision of LinkedIn as a company is essentially a very inclusive vision. The vision is to create economic opportunity for every member of the global workforce. And so I've taken the liberty of adding the emphasis on every member, but it is really something kind of fundamental and core to our vision. And so that includes, right, members who are not born with a great social network, members who don't have a traditional education, includes really members of all backgrounds. And that also includes members who are not already power users, right? We don't want to just optimize for a small group of people. We want to build a platform that benefits everybody. And when we mean benefit everybody, we mean that ideally two people with equal talent should have equal access to opportunities. And there are plenty of opportunities at LinkedIn, and these will translate in terms of the metrics we actually look at as we assess the inclusiveness of our experiments. But on LinkedIn, you have opportunities to build a network, to find a job, to engage with content, to get novel information, to be referred to a job. We also have LinkedIn Learning, where you can learn and also to get endorsements on your skills. And so all of these things, but all these opportunities that translate to meaningful professional opportunities for our members that potentially have an impact on their lives, we want to make sure that those are distributed as equally as possible. And of course, it's a very challenging problem that technology cannot solve alone. And we're making all sorts of R&D investments in that space. And so what I'm going to be presenting here today is primarily one aspect, which has to do with experimentation and inequality. And I'll define inequality. We're really looking at inequality where an economist would look at inequality here. And so here's the very kind of high level structure of what I want to talk about today. First, I'll talk a little bit about why A/B testing is, in our view, important when we're trying to build an inclusive platform. I'll go a little bit over what we're measuring and why. And I'll talk about our process to inform decisions as we see the A/B test results and the metrics when it comes to inclusion. And finally, and perhaps the thing that I'm looking forward to the most, is to give you a high-level overview of the things we've learned reviewing thousands of experiments. So the things that just seem to reduce inequality and the things that seem to increase inequality from reviewing many experiments over, I think at this point, almost a 2-year period. And so why A/B testing, right? And so the first thing is like, well, unfairness, a very simple, very broad definition is something like having unequal outcomes or unequal treatment without a mechanism that is deemed just. And so, this has been documented in children, this has been documented even in other primates, that if they behave the same way and you give them two things that are different, you'll get a reaction. So there seems to be this very kind of innate reaction to being treated differently unless there's a really good reason. And so, imagine we see a large gap between two groups. We see some groups, some people, there's a group of really highly engaged power users and a group of people left behind. The issue is that, LinkedIn users are constantly interacting with a very large number of features all the time. And so it's very hard to figure out, well, why is there a gap between these people? Why is there inequality there? And so to fix the gap, we need to identify its origin. And this is where A/B testing helps, because if you A/B test every single new feature, looking at the impact it has on inequality and opportunity in the opportunity distribution, then you can go back and say, well, it seems like the inequality, the concentration of opportunities seem to have started around that time, around that experiment. And so in a sense, what we'll do is for each new feature or each change in features, we'll ask, okay, is this change going to make outcomes more equal or more unequal between our members? The other reason it really matters, we think, is because, if you see a gap between two groups of people or between highly engaged members and not highly, if you see any sort of inequality, say very high Gini coefficient or something like that, right? Yes, it can come from some sort of a biased algorithm, but it can also come from the fact that even though you treat people fairly and completely the same way, somehow they're reacting differently. a treatment that is otherwise unbiased. And in fact, we've seen this happen with things as simple as copy changes. We just change the wording of something, and we see that some members react very, very differently than others. And so the point of A/B testing is to try and catch the overall effect of introducing a new feature, not just kind of to look at the process of the feature itself and what the feature does, but also how our member interacts with it. Because at the end of the day, if there's any feature that changes meaningfully the distribution of professional opportunities on our platform, well, that's something we want to know. And so, what are we measuring? Well, essentially for A/B testing, we're using two complementary approaches. The first one is the one I'm not going to talk about very much today, but it's the simplest, which is essentially a fully group-based approach, where essentially we look at the impact of a new experiment on two different populations. So for example, we can say, hey, this feature increases engagement by 5% for group A and by 3% for group B. There's a difference there. Would you like to look at this some more? And so for now, we're actually looking at for every single experiment, we actually assess members with a very good network, which we call high social capital, and members with a network that still has to be grown and diversified, which we call low social capital members. But we also look at something else, and this is probably the thing I want to focus on today, which is what we call inequality impact. And that's a kind of more general approach, which looks at inequality the same way economists would look at income inequality. So if you've read the press or heard some debates recently, there's a lot of emphasis on inequality in the U.S. and I'm not making any statements about that, but the kind of metric that's used there, it's something about the distribution itself, which is say their share of the top 1%. Right. And the fact that maybe the rich are getting richer. And so the question is like, is it the same on LinkedIn? Are the rich getting richer? Are people very engaged getting even more engaged? And people getting lots of job offers getting even more job offers? And if so, can that be attributed to our experiments? And so an example insight for this is like, hey, your feature increases inequality in engagement and contributions. And so the gap between high engagement and low engagement members is widening because of these features. Are you okay with that? And so how do we measure inequality impact? And so again, this is really the way economists look at inequality. And so imagine, for example, LinkedIn has 10 members, and each of them has one useful conversation a day. And useful conversation, let's call that our opportunity metric. It is that thing that measures something meaningful for a member's career. And so if the experimentation platform tells you, hey, we have this new feature and it increases these useful conversations by 1 per member per day on average. So in other words, everyone here, every person is a blue bar here. And so what you imagine happens is that everyone has 1 conversation a day, and then the next day after, after you A/B test or, in your treatment group, everyone now has 2 useful conversations a day. Right. And this is usually what people tend to assume when they look at an A/B testing dashboard. And the problem is what could be hiding under that statistic that I just given you, that average number, is something like this. And in fact, we see this happen fairly often, where essentially some members might actually get fewer conversations a day, fewer useful conversations, and some members might benefit from the feature tremendously. So of course, this is a highly stylized example, but the way I've set this up is that both of these scenarios, they look exactly the same on average. It's still a doubling of the total number of useful conversations. However, of course, right, in terms of building an inclusive platform, a platform that serves everybody, clearly these two things need to be distinguished. And so this is essentially what we're going after as we're measuring inequality. And so that is kind of the high level intuition. And the way we do this is essentially using the Atkinson index, which is very, very common in economics, to compare the income distribution between countries, to compare wealth distributions. And I've put the formula here. It's applicable to any metric that's not a binary metric, so sessions, contributions, job applications, what have you. And it's really great at measuring whether opportunities are getting more or less concentrated. And so an example insight here would be, hey, your feature has a 2% lift on engagement, but it's increasing the concentration of engagement. Would you like us to do a deep dive? And I'll talk a little bit about how we do these deep dives and what the decision process looks like after that. So one of the ways you can interpret this result, one of the nice properties of the Atkinson index, is that with some modeling, you can actually think of it as a discount factor on the total of the metric. In other words, like, you have some utility, say as a decision maker, for increasing your sessions by a certain percentage, but there's a discount on that utility because that increase is not equally distributed. And this is how economists typically model the way a social planner might decide to do redistribution or might feel about a specific distribution of income. And what's nice about this is we can actually use choice experiments to calibrate this to get a sense of what the epsilon should be. So the reason why, I mean, there's many reasons why inequality impacts defined like this, right? Defined as this economic inequality in the sense of just purely distributional. There's many reasons why it can be useful. First of all, we can catch feature that create unintended gaps or that close gaps between members. So we can catch things that increase or reduce inequality of the distribution. So it can serve as it can actually serve as a great guardrail, because the alternative is you have to specify 20 groups that you care about or 100 groups that you care about and make sure that, these things, that there's no inequality between these groups. And if there's a group you don't have data for, or you don't know how to monitor, or you're not allowed to monitor, then you might not catch this effect. It's also helpful to put a number on some experiments that might look neutral in a simple t-test, but still reduce inequality, right? Because that is potentially a goal for a company, is to make sure that there's more and more people that are involved, and that the people who have low involvement in the platform, and I mean that both by sessions or by job opportunities, that their number goes up. In other words, even an experiment that might not have a positive impact on the total of the metric, you might still want to launch it. I mean, and make it your main experience if it reduces inequality, if it makes professional opportunities more equally distributed. We don't need to specify segments of interest, so we don't need, for this at least, to give an exhaustive list of all the groups we care about. I mean, there's still a lot of value in doing that, and we're also doing that, but at least we don't need it for this specific method. And for those of you who kind of stared at the formula up there, you'll see that it's actually very, very scalable. And in fact, we're open sourcing this on Spark, but it's extremely fast to compute Atkinson indices for thousands of experiments in a way that's very scalable. And part of it is because, contrary to a Gini coefficient and some other metrics, this is decomposable as an addition. And so you can essentially, it lends itself very well to Spark or to MapReduce. So once we have, so what we do is we actually compute these Atkinson indices. And if we see a strong positive or negative inequality impact, then what do? Well, essentially, there's a review council that sits, just about every month, sometimes every couple of months, and reviews the experiments that had the strongest inequality impact, both in terms of increasing inequality the most and decreasing inequality the most. And so, the goals of these monthly meetings is essentially to inform, so to educate product owners and product managers about the impacts that they're having, and we show them a series of charts and representations of quantiles and potential deep dives. And the point is not to just be the police, but it's to inform. And we also want to promote and say, if your goal is to reduce inequality, well, here are 5 initiatives of yours that just seem to have worked. And so maybe you want to do more of those initiatives. And also for us, and this is what I'll share a little bit towards the end of this talk, is to build a knowledge base, which is what are the kinds of experiments, what are the kinds of features for a big social, social network like ours that seem to lead to more equally distributed professional outcomes. And so it's about, kind of, you can think of it, as opposed to kind of top-down fairness where you pick a metric and you kind of enforce it. This is much more kind of like bottom-up fairness, where all sorts of teams are trying all sorts of experiments, and we just happen to see which ones reduce inequality, and then we have a review to decide whether or not we think that's making outcomes more fair. And so the process is we monitor all experiments. We select the ones with the most significant impacts. We invite their owners. We provide that feedback that I've described, and we have this informational meeting. It's not that we're after anybody to say, hey, don't do this. We just want to make sure that if people are after more equally distributed outcomes, we give them the means to measure this. And so, what we've learned so far, I want to share a couple of examples of some of the things that we've learned. So as I mentioned, we've looked at this for many experiments, and we've been able to extract kind of some high-level lessons in terms of the kinds of experiments that seem to reduce or increase inequality overall. And so high-level findings is, the first one is we should really pay special attention to business-neutral experiments. And so in a number of companies, a lot of experiments are run hoping for a null result, hoping that there's no significance. And that might be experiments, for example, where you change something in the backend, or you change the way the site is rendered. You change some sort of backend system, And you just want to make sure that there's no regression, that it's not actually hurting members, that it's not hurting the metrics, that it's not hurting site speed, for example. And so a surprising number of experiments actually are meant to check that we're not hurting metrics, not necessarily that we're increasing these metrics. And yet we found in many instances that these experiments may look neutral on average, but they may actually have an inequality impact, which is they can have this rich get richer impact, which is people with already high sessions, already very fast devices get a lot more speed, for example, and people with like poor devices get even less speed. But on average, it looks okay. So people might think mistakenly that it's neutral. And here, what this helps us emphasize that there's a difference between being business neutral and being really neutral in terms of the impact we have on our members. Notifications are a very powerful tool to reduce inequality. And so notifications are the tool that we use to bring people back to the site. And I'll give you a more precise example in a minute. But essentially, it turns out that like specific notifications, targeted notifications, can be a great tool to bring people back to the site and to reduce inequality, not just in engagement, but also in job applications and in professional opportunities. We've also found a number of experiments where the site speed had an impact. And so trying different kinds of rendering and also the slow speed version, the low bandwidth version of LinkedIn, many experiments that had to do with these actually had a very positive impact. And so different features that were trying to essentially work better for people with lower bandwidth or lower speed devices seem to really reduce inequality in the outcomes that we care about. Reducing inequality can lead to a member-member experience, and so we've seen this in a couple of occasions, especially on the feed. So when inequality in terms of who contributes to the feed gets reduced, it seems like overall the member base benefit. But by and large, right, what really jumped out at us after having all these conversations is that both positive and negative inequality impacts are very often unintended. And so when we go to the team and try to have this conversation, it often comes as a good or maybe not so good surprise to them that this is happening. And of course, especially the teams who go in thinking that their experiment is going to be quote unquote business neutral. And so with this, we're essentially building ourselves a little book of these experiments and of these different kinds of things that we know now seem to have an impact on inequality. And so I want to just deep dive on one example to give you a flavor of what we're doing. And before this, just to give you a quick primer. So at LinkedIn, we have this one measure that we use on occasion, which measures essentially the local clustering coefficient of a person's network, which is how structurally diverse the network is. Because some people have connections that are extremely redundant. So here in this picture, Bob, for example, all of Bob's connections know each other, and Alice here, her connections don't know each other on average. And we know through half a century of social networks literature that generally speaking, having a more open network, a more structurally diverse network, where Alice is here, bridging two different communities, that's typically good for you and for your career. And so when we run these experiments, we actually also look at the impact depending on the type of network that the member has. And so here, you can compute an openness score, and you can see that Alice's network is more open, more structurally diverse than Bob's network. And so the first experiment that really jumped out at us actually was this Insta Jobs experiment. And so what this is, and this is something that now everyone can have access to on LinkedIn, which is active job seekers now receive a push notification within seconds when there's a relevant job that's being posted. Beforehand, you had to wait to organically hear about the experiment, hear about the job posting. So either someone referred you, or you saw it on your feed, or you went to look for it, and now instantly you get a notification. And so the impact was actually pretty interesting, which is there was a positive impact on job interactions, which is what we cared about for this specific experiment, but there was a tremendous reduction in the inequality metric, in the Atkinson index. In other words, people who had few job applications seem to be getting more, right? The difference between the bottom and the top of the distribution in terms of job applications was reducing a fair bit. And so that seemed pretty encouraging. And then we looked and we did a deep dive, and we actually looked at this social capital metric, that I just described. And what we saw is like most of the effect was concentrated on members with closed networks. So people who don't have extremely powerful social networks that are redundant, maybe say, think of like a high school network. And so, that was a very powerful finding, because this is an example where an algorithm can actually enhance inclusion by substituting for a not so strong social network. And so here, this was a really kind of powerful finding. And so how we detected it with the Atkinson monitoring system it seemed interesting, and so we did a deep dive, and these are the kinds of results that we found. And there's all sorts of evidence that suggests that some members, if they don't have a strong social network, they may not receive the job. And so this is where getting a notification really helps. And also some people might self-censor from applying to a job. And so this is where getting them the instant notification instantly, where they don't see that a bunch of people applied already, also really helps. So I'm almost at time. I just want to show you the other some of the other elements of the UI. So we actually also show a bunch of distributional statistics. And so this, for example, shows the impact by quantile. And so this experiment, you can see that the top 1% is getting a big boost while everyone else is suffering for this specific experiment. And also want to share that all of this is on GitHub. I'm leaving the link here. And so if you need to compute inequality at scale using Spark, please check this page out. And that's it. So I'm very happy to answer questions now. Thank you so much for your time and attention.